All right, this is part 3 of 8.3. So this is our last video to finish off section 8.3. In this section, we're going to talk about effective annual yield. So the effective annual yield, or the effective rate, is the simple interest rate that would produce the same amount of money in an account at the end of 1 year as if that account was subject to compound interest. So remember, you have simple interest that's only calculated on the principal. And then you have compound interest that's calculated on the principal and any interest that you accrue. A little bit different, right? And so if you have a compound interest account at a certain rate, let's say 5%, and it's compounded each year, what simple interest would you have to get to make your money equivalent? Probably a little bit more than 5% because it's not compounded. So we're going to work this kind of idea backwards, and then I'm going to show you that there is actually a formula that we can use to find the effective rate or the effective annual yield right away. Okay, let me show you. Example number 5 says that you have $4,000 and you deposit that $4,000 in an account. It pays 8% interest compounded monthly. $4,000, 8% compound monthly. So it's not simple, it's compound. It's not continuous, it's monthly. So I know that there's a formula I can use to figure out my future value after 1 year. Now, you can use the one for 1 year, or you could actually use the compound interest formula for any amount of time, and it will work out to be the same. Let me show you. So I'm going to use my compound interest formula that we were just using in the last video. That says I can find my future value of any compound interest amount. I know that I have $4,000 that I'm going to put in the account. I know that the interest rate is 8%, so 0.08. The N, remember, is the number of times a year that this is being calculated. So I know that this is being calculated monthly, and I'm going to do it for 1 year. Okay, so let's figure out after that 1 year how much money I'm going to have in my account. So enter it in your calculator. Remember to do it in the right order of operations. Pause your video if you need to, and make sure you get the same answer as me. I ended up getting, at the end of that 1 year, $4,332. At the end of 1 year, I started with $4,000, and I ended up with $4,332 total. So I just earned a little over $300 in interest. Pretty cool, right? Because all my interest was compounded each month in order for me to get more interest. So let's think of that same bank account, and let's use our future value formula for simple interest and figure out what simple interest I would have needed to have earned so that I end up having the same amount of money in my account as this compound interest account. I want to find my effective annual yield. Okay, so I know that this first account, I don't know, Bank A, had compound interest. But I really want to bank at Bank B, but they only give me simple interest. I've got to make sure that Bank B gives me enough interest so I'm going to have the same amount in my account versus Bank A. So I'm going to start with my simple interest formula for my future value. Remember, if you look on your formula sheet, it should be on the front page at the bottom. I have future value with simple interest using this formula right here. A equals P times 1 plus RT. This is going to give me my future value with simple interest. And let's use the numbers that we got from Bank A, plug it into this formula, and let's see what Bank B would have to give me as a simple interest rate in order to be the same amount. So we end up with a future value. How much do we have to have in the end? Well, we end up with the 4,332, right? That's how much we wanted to have in the end if it's going to be equivalent to Bank A. We wanted to end with that much money, $4,332. We know that we put in $4,000 into the account. We don't know what the simple interest rate is going to be. That's what we want to find out. They gave us 8% in the compound interest, but that was given to us every single month. So what would have to happen if it wasn't compound interest, if it was simple interest? How much would they have to give us? So let's look. The time, remember, is years, and how many years were we going to leave it in the account for? Well, that's right, 1 year. And so my problem looks like this. I'm going to simplify this a little bit, make this look a little bit nicer. I have 4,000 times 1, so that's 4,000. I have 4,000 times R, really, because R times 1 is just 1R. And then I'm going to solve for R. I want to figure out what that interest rate has to be in order to help me figure out what simple interest would be equivalent. I'm going to solve this equation now by subtracting 4,000 to both sides. And I'm going to divide by 4,000 to isolate that R, to get R by itself. So in my calculator, what's 332 divided by 4,000? I ended up getting 0.083. But remember, this is an interest rate. And interest rates are normally given as percents, but this number that I have is a decimal. So what simple interest would I have to earn in Bank B in order to make my money equivalent to just banking with Bank A? Remember, we've got to move our decimal place over twice, and my effective annual yield, or my effective rate, my simple interest rate, would have to be 8.3% if they're just going to give me simple interest in order to make sure that I have the same money in my account as Bank A. So now I could either choose Bank A, I could choose Bank B. As long as Bank B gives me 8.3%, then they would end up being the same amount of money. So the simple interest rate has to be a little bit more in order to make sure that my money is equivalent. Okay? So we did that the long way. That was a lot of work in order to figure out that simple interest amount, my effective annual yield. Instead, look at this formula. What we could have actually done is use this formula now to cut out all of those different steps and still get the same answer. Let me show you. Remember, this formula is on your formula sheet on the back side, so make sure that you know where that's at for the test day. It says here that Y is going to give us our effective annual yield, that simple interest rate that we found before. R is the interest rate that was given to us in the compound form. N, remember, is the number of times a year they were going to compound that interest. We can use this formula to help us figure out the effective annual yield without doing all of that work up above. Let me show you. We have our interest rate in that other account. What was that first bank? Bank A was going to give us 8%, right? 0.08. It was going to compound our interest monthly. How many times a year was that? 12. And so I'm going to put the 12 at the denominator and 12 in that exponent, minus 1. So as long as I plug in all the information from the compound account into this formula, and I calculate it with my calculator, that's going to tell me what simple interest, my effective annual yield, would be for Bank B. Let's put it in our calculator and see what we get. So I have parentheses, 1 plus 0.08 divided by 12, parentheses, raised to the 12th power equals, and then minus 1 equals. I ended up getting 0.08299. Let's write it down. 0.08299, something like that, and it kept going, right? So if this is an interest rate, though, I would have to move my decimal place over to get a percent. If I have 0.2, and I'm rounding it to 2 decimal places, but there's a 9 in the back, wouldn't that really be 8.3? And so wasn't that the same number that we got before doing it the long way? So next time on your test, when I ask you to use the effective annual yield formula, it is much easier to use that formula to get the effective annual yield than it is to work out all those steps up above. So make sure that you know how to use that formula so you can quickly calculate for me the effective annual yield. That's the simple interest rate that you'd have to get to make it equivalent to that compound interest rate. Okay, let's try one more real quick with new numbers, finding the effective annual yield. So it says here a passbook savings account has a nominal rate of 5%. The interest is compounded daily. Find the account's effective annual yield. Okay, here's the tricky part. Daily, we always think of as 365, but banks actually use 360. It started a long time ago when, before they had all this technology and calculators, that 360 was easier to divide by, and they've actually just kept it 360. Probably because that means that they have 5 less days they have to give you interest on, right? But we're going to use 360 because I think that's how my math lab does it and how most banks do it right now, even though that there's a little more than that in a year. We know that, right? All right, so it says here, find the effective annual yield. So I know effective annual yield can be calculated using that simple formula instead of doing all the steps like we did up above. And all we have to do is have all the information to plug in. So here we go. It says here an interest rate of 5%, so 0.05. It says that it's compounded daily. Remember, we're going to use 360 instead of 365. And then all we have to do is punch it in our calculator. Remember to do it in the right order. You try it, and let's see if we get the same number. So if we're talking about interest, remember we need a percent, so we need to move our decimal place over. And what interest rate would be the same as 5% compounded daily? Well, that would be a simple interest of 5.13%. You would have to make sure that you get 5.13% if it was simple interest versus only 5% if it was compounded daily. Much easier than doing all the steps that we did up above. So make sure you know how to use that effective annual yield formula. That concludes 8.3.